Hi everyone. Today we're going to talk about sample spaces and probability. So just some very simple probabilities for today. The assumption is going into this topic that you do know your notation. So things like A and B versus A or B. So it's really important that if you're not 100% confident with those sorts of things, that you do revise before jumping into this, especially if you are doing something like Year 11 methods. Now, when it comes to sample spaces and probability, there are a couple of definitions that you really need to understand the meaning of, okay? In probability, when we talk about a experiment, we're talking about some sort of procedure where we can continue to repeat it and that each repetition has a possible set of results that are the same, okay? And so, for example, I could think of, let's say, rolling a six-sided die, right? Because I can continue to do that. And my outcomes remain the same whenever I roll that die. Now, a trial is just one performance of that experiment. So I might consider an experiment to be rolling the six-sided die, let's say 50 times, right? And so a trial is just rolling it once instead of all 50 times, okay? The outcomes are just your possible results of an experiment, okay? And so for a six-sided die, that's going to be things like 1, 2, 3, 4, 5, and 6, right? They're all the possible outcomes, and we write them in a sample space. And for that, we use our set notation, being those squiggly brackets, okay? And then you have an event, which is one or more possible outcomes in an experiment. So for rolling a six-sided die, we could have something like rolling a 4, but we could also have something like rolling an odd number. And so instead of just having the numbers 1, 2, 3, 4, 5, or 6, you could say, well, I want to roll an odd number. So it could be a 1, 3, or 5. If we were rolling 2 dice, it could be something like rolling a double instead. Now, some of our key ideas for probability are that we measure between 0 and 1. Okay, now we like to use fractions. There are some cases where we will use decimals. However, we do not use percentages. Okay, so that's a really key one there, is that there are no percentages in probability. Now, for any event A, our probability is always going to be greater than or equal to 0 or less than or equal to 1. And we can find very simple probabilities just using the formula below, being the number of favourable outcomes over the total number of outcomes. Okay, so for example, if I had rolling an odd number for that six-sided die from before, our total number of outcomes is 6, and then our favourable outcomes were 1, 3, and 5. So there were 3 favourable, meaning that our probability there is a half. Now, if you're confident with probability and are just using this to recap, feel free to pause here and I'll go through it. If we have a bag containing 7 marbles, 1 to 7, right, we've just got marbles we're assuming are evenly sized, being picked out of a bag. So it's very similar to our six-sided die. So our sample space for this experiment is going to be those numbers 1 through to 7, okay? Now, outcomes of the event, an odd number is drawn. We once again use our set notation for that, and that's going to be 1, 3, 5, and 7. So if we want the probability of an odd number being drawn, that's going to be 4, because that's our number of favourable outcomes over the 7 possible outcomes. Now, one thing that we really like to use in maths is something like a standard deck of cards, and that's because we can just ask so many questions about it. Right, so it's really good for you to remember what's in a standard deck of cards, just because they're really useful to mix up your probability questions. Now, in a standard deck of cards, we've got 4 suits and 2 colours, and then we've got our number and our picture cards. So, in a deck of cards, the chance of a card being black, considering we've only got the 2 colours, is going to be 1/2, all right? But that would start out as 26 over 52. The probability that the card is a king, well, in a deck of cards, we have 4 kings, 1 of each suit. So it'd be 4 over 52, which would simplify down to 1 over 13. Now, if we're looking for something like a king of spades, there is only one king of spades because each suit only has one of each. So the probability of a king of spades is going to be just the 1 out of all 52. Now, the probability that we have a number card, and we do include aces in the number cards, we have our numbers 1 through 10 here, and times that by 4 is going to be 40 over 52, which is going to be 10 over 13. Okay, and that's because those other 12 cards are our picture cards. Now, once again, feel free to pause here, but the main idea is that our total probabilities are going to add to 1. Okay, so to find the probability of obtaining a 4 when we only have the 4 outcomes is just to start with 1 and take away all those other probabilities. Okay, that means we're going to have 13 over 13 taking away 6 over 13. And so the probability of a 4 in this case is 7 over 13. Now, the other thing you have to be quite confident with is this idea of complementary events. Okay, so when we have two events that have no outcomes in common and they make up the entire sample space together, those are said to be complementary. Right. So, for example, being an only child is complementary with having siblings because they're opposite events. Okay. And so if we had rolling a 2 on a 6-sided die, then the complementary would be rolling a 1, 3, 4, 5, or 6. And so what that means is if I have an event A and I have its complement, that together they're going to add up to be 1. Okay, and we can use this to our advantage. If we know the probability of something not happening, we can find out the probability of it happening. And so if we look at something like that standard deck of cards from before, we're going to find out the probability of something not being a heart. And the easiest way to find that out, instead of counting all your not heart cards, is to find out, well, how many are actually a heart, and then take that probability away from 1. Now we've got 4 suits in a deck of cards, so we know that the probability of a heart is going to be 1 out of those 4. And if I take that away from 1, we're left with 3 quarters. Now, similar idea for not an ace. It's going to be very lengthy counting up all your cards that are not aces when the number of cards that are aces are a lot smaller. And so we can find the number of aces, in that case being the 4 out of 52, being that 1 out of 13, and take that away from 1. So we're left with 12 out of 13. So there are times when finding your complementary is going to be easier than finding, counting all the possible outcomes. Now, feel free to pause here. There's just one last little check to make sure that you all know what's going on. But we've got 5 outcomes here, A, B, C, or D or E, and we've got that A, B, C, and D are equally likely, and E is twice as likely as A. So what this means is that we've got A plus B plus C plus D plus E being equal to 1. So I'm going to assign X to A, B, C, D, or E. Or sorry, just A, B, C, or D. And so we've got 1 over X plus 1 over X plus 1 over X plus 1 over X. And then E is twice as likely to happen, so that's going to be 2 over X. We're then left with 1 is equal to 6 over X, so X is going to be equal to 6. Okay, so the probability of E happening is 2 over 6, which is 1 over 3. Now, the probability of B not happening is the same as 1 minus the probability of B, okay, which is just going to be easier than adding up all the probabilities. Now we can see from what we found before that the probability of B is 1 over 6, and so the probability of B not happening is 5 over 6.